Assalamualaikum warahmatullahi wabarakatuh and hi. Today I want to discuss about chapter 2, which is kinematic of linear motion. First of all, we go for the learning outcomes. 2.1 is the linear motion. 2.1a is define instantaneous velocity and uniform velocity. Define instantaneous acceleration, average acceleration and uniform acceleration. 2.1b discuss the physical meaning of the displacement time, velocity time, and acceleration time graph. 2.3 is the projectile motion. 2.3a describe projectile motion launches at angle theta as well as special cases when theta equal to 0 degree and theta equal to 90 degree. So what is kinematic of linear motion? Kinematic of linear motion is the studies of motion of an object in a straight line without considering the effect that produces the motion and what causes the motion. There are two types of motion. The first type is linear or straight line motion, consists constant velocity and constant acceleration, for example free fall. Next type is projectile motion, consists of x component and y component. So first learning outcome is define instantaneous velocity, average velocity and uniform velocity. Before we go for the velocity, we revise what is speed. Speed is rate of total distance travel and the speed is scalar quantity and the unit of the speed is meter per second. While velocity is a vector quantity but the unit is same with the speed which is meter per second. Average velocity. The average velocity is defined as the rate of change of displacement. We can write down the equation of average velocity is the change of displacement over time interval, or S2 minus S1 over T2 minus T1, and we can write down the average velocity is equal to delta S over delta T. Its direction is in the same direction of the change in displacement. What is instantaneous velocity? Instantaneous velocity is defined as the instantaneous rate of the change of displacement. And we can write down the equation V is equal to ds over dt. An object moves in a uniform velocity when ds over dt equal to constant. And the instantaneous velocity equal to the average velocity at any time. Let's say we have the displacement time graph, and this is the increasing displacement time graph. The gradient of the displacement time graph is equal to velocity. Let's say at point Q, the gradient of the tangent to the curve at point Q is equal to the instantaneous velocity at time t equal to t1. Next learning outcome is define instantaneous acceleration, average acceleration, and uniform acceleration. Acceleration is a vector quantity and the unit of the acceleration is meter per second square. Now we continue with the average acceleration. Average acceleration is defined as the rate of change of velocity. The equation of the average acceleration is equal to change of velocity over time interval, or we can write down by using the symbol is equal to v2 minus v1 over t2 minus t1, or we can write down the average acceleration is equal to delta v over delta t. Direction of the average acceleration is the same direction of the change in velocity. And the acceleration of an object is uniform when the magnitude of the velocity changes at a constant rate and along fixed direction. We continue with the instantaneous acceleration. Instantaneous acceleration is defined as the instantaneous rate of change of velocity. The equation of the instantaneous acceleration is equal to dv over dt equal to d square s over dt square. An object moves in a uniform acceleration when dv over dt equal to constant, and the instantaneous acceleration equal to the average acceleration at any time. Next one, we go for the deceleration. Deceleration is a negative acceleration. The object is slowing down, meaning the speed of the object decreases with time. Now we have the graph of Vt graph, and this is an increasing time graph. and we have the gradient at point Q. So the gradient of VT graph is equal to the acceleration. The gradient of the tangent to the curve at point Q is equal to the instantaneous acceleration at time t equal to t1. Next learning outcome is discuss the physical meaning of the displacement time, velocity time, and acceleration time graph. First, we go for the displacement again time graph. When analyzing displacement time graph, always remember that the gradient of the graph represents the velocity of the graph. For the first graph, the graph is a non-horizontal straight line, so the gradient is not equal to 0. For a slanted straight line, the gradient is constant, so the velocity of the moving object is uniform. For the second graph, the graph is a curve, show that the gradient is not constant. The gradient increases over time, indicates that the velocity increases over time. For the third graph, you can see at point P, point Q, and point R. The point P is the same with the A graph, while for point R, the graph is a non-horizontal straight line with negative gradient. The negative value of the gradient indicates that the object moves in opposite direction. Therefore, this graph represents a motion with uniform velocity in opposite direction. While at point Q, showing a horizontal straight line, so the gradient is equal to 0, which means the object is stationary or the object does not move. Next one is we discuss the velocity versus time graph. When analyzing velocity time graph, always remember that the gradient of the graph represents the acceleration of the graph. For the first graph, the graph is horizontal straight line, so the gradient is equal to 0, and this means the object moves with uniform velocity, and the acceleration is equal to 0. While for the second graph, the graph is a non-horizontal straight line, so the gradient is not equal to 0. For a slanted straight line, the gradient is constant, so the acceleration of the moving object is uniform. For the third graph, you can see at point A, point B, and point C, the point A is the same with the second graph. The gradient is the positive, meaning that the object is speeding up. At point B, the gradient is 0, so the acceleration is 0. And at point C, the gradient is negative, means that the object is slowing down. The next information we must know is that the area under the VT graph equal to the displacement. Next, we go for the projectile motion. What is projectile motion? Projectile motion is the motion of an object thrown or projected into the air, the subject to only the acceleration of gravity. The object is called a projectile and its path is called trajectory. So, the projectile motion consists of two components. The first component is the vertical component or y component. Motion under constant acceleration, ay equal to negative g. While the second component is horizontal component, which is x component. This means that motion with constant velocity. So, ax equal to 0. This is some example of the projectile motion. The x component of velocity along AC horizontal at any point is constant. So, ux equal to u cos theta. The y component vertical of velocity varies from one point to another point along AC. So, the equation of uy equal to u sin theta. So, this is the equation of velocity at point P and at point Q. So, we have the x component, all the x component ux, v1x, v2x. And the y component is uy, v1y, and v2y. At the point P, the x component is v1x equal to ux equal to u cos theta, while at point Q, the v2x equal to ux equal to u cos theta. While for the y component for the point P, v1y equal to uy minus gt1. For point Q, v2y equal to uy minus gt2. And the magnitude of the velocity at point P is v1x square plus v1y square third. And v2 is equal to third of the v2x square plus v2y square. And to calculate the direction is theta 1 equal to reverse of v1y over v1x, while theta 2 equal to reverse of tangent v2y over v2x. So we go for the first question. Figure 1 show a graph of displacement s versus time t for two cars P and Q moving on two straight parallel tracks. Which of the following statement is true about the motion of this car? So we have the displacement time graph. One is P curve and one is for the Q straight line. So what is the answer? A, P and Q move the same distance in time t1. Correct. Next question is, the change in the magnitude of the expression A of an object with time t is shown in figure 2. So we have the AT graph. 0 until t is uniform expression. T until the end is the expression equal to 0. So which one is more possible answer? The answer is D. Increasing velocity with time. So this one is uniform expression. And the moving with uniform velocity. So moving with uniform velocity, the expression is equal to 0.